What's up, all you cool cats and kittens? Today we're talking about graphing linear equations. We're going to talk about two forms of an equation, standard form and slope-intercept form. We have two different forms of the linear equation. We have standard form, ax plus by equals c, and we have slope-intercept form, which is y equals mx plus b, made up of the slope and the y-intercept. First, we're going to talk about getting the x-intercept from standard form. You're first going to take ax, and you're going to set that equal to c. The reason why is because we would plug in 0 for y. So if I covered up by, all I would get left over is ax equals c. We'll take a look at that example with numbers in just a minute. If I'm looking for the y-intercept, I'm going to do the exact opposite. I'm going to take that by and set it equal to c. The reason being, if I wanted to find the y-intercept, I would have to plug in a 0 for x. That would leave me with by equals c. We'll look at an example with that with numbers in just a minute. When we're looking at slope-intercept form, the number that's in front of the x is called our slope. You may remember this as rise over run. We represent it with an m. Our b value, the last number in slope-intercept form, is our y-intercept. That's where our graph is going to pass through the y-axis. An x-intercept is a number, comma 0, where our graph passes through the x-axis, and our y-intercept is 0, comma a number. Our first example is in standard form, ax plus by equals c. We're going to go ahead and find the x and y-intercepts, and then we'll sketch a graph. If you cover up the y value or you plug in a 0 for y, you'll be left with negative 5x equals negative 12. That's that ax equals c I was talking about before. We're going to go ahead and solve that like an equation. The y-intercept is the exact opposite. We could cover up the x value or plug in a 0 for x and set up the equation 6y equals negative 12. That's that by equals c I was talking about. Go ahead and solve that. If I divide by negative 5 on both sides, I'll end up getting x is equal to positive 2.4. If I solve this other equation to find the y-intercept, I'm going to end up dividing by 6 on both sides, and that'll give me y equals negative 2. This will leave me with 2 points that I can plot on a graph, 2.4, comma 0 and 0, comma negative 2. After I sketch a graph on the right-hand side of my page, I'm going to take a look at the x-axis and find that 2.4. Then I'll take a look at the y-axis and I'll find that negative 2. These are my x and y-intercepts. All you need is 2 points to make a line. Once you plot those 2 points, you can connect the dots, and boom, there's your line. Let's go ahead and convert this to slope-intercept form. I want to get y by itself, so I'm going to go ahead and add that 5x to the other side, which will leave me with 6y equals 5x minus 12. I put the 5x first because remember, I want this to look like mx plus b. I can divide by 6 on every single piece, which will leave me with y equals 5/6 x minus 2. Notice how my slope is 5/6, the number in front of x, and my y-intercept should match that work that I did before, 0, negative 2. I'm going to graph this now using y equals mx plus b. So start at your y-intercept, negative 2, and plot a point. Then you want to use your slope. This is positive, so I'm going to move up 5 to the right 6, rise over run, and plot a point. Again, I only need 2 points to make a line, so once I find those 2 points, I can connect the dots. Notice how this is going to have the exact same x-intercept that I found before at about 2.4, comma 0. And it has the same exact y-intercept because it's the same line. We just converted it from standard form to slope-intercept form. Remember that slope is a formula, y2 minus y1 over x2 minus x1, the changes in y's over the changes in x's. So I'm going to go ahead and label that new point and my y-intercept x1, y1, and x2, y2. That just means the first point and the second point. When I plug those into that formula, 3 minus negative 2, y2 minus y1, over 6 minus 0, x2 minus x1 is going to give me 3 plus 2 is 5, and 6 minus 0 is 6. So notice that these slopes match. Let's go ahead and take a look at example 2. Notice how this is in slope-intercept form. We're going to find x and y-intercepts and sketch that graph. So to find your x-intercept, you want to plug in 0 for y. So I'm going to have 0 equals 2x minus 9, and I'm just going to solve that like an equation. I'm going to add 9 to both sides. I'm going to get 9 equals 2x. Now you're just going to divide by 2 on both sides, which will give me 4.5 equals x. That's my x-intercept at 4.5 comma 0. Remember, that's the point where the graph crosses the x-axis. When I find the y-intercept, I want to do the exact opposite, and I want to plug in 0 for x. So this time I'm going to have y equals 2 times 0 minus 9. And we're going to go ahead and solve this problem. Anything times 0 is always going to give you 0. So that's why our y-intercept is 0 comma b. Notice how that b value in my y equals mx plus b equation is the same y-intercept that I'm finding when I do this algebraically. Let's go ahead and sketch this graph using slope-intercept form. Remember that my slope is the number next to x, so I'm using 2 over 1. I can move up 2 and then to the right 1 because my slope is positive. We'll start at the y-intercept at 0, negative 9, and we'll go ahead and count 2 up, right 1. 2 up, right 1. And we'll continue that pattern as long as we want. Remember, we only need 2 points to make a line, but I want us to see that we can see our x-intercepts and our y-intercepts in this line. Here's my point 0, negative 9, my y-intercept, and you can see that 4.5 comma 0 is on that line. We can also convert this into standard form. All I need to do is move that x value to the left side, so I'll subtract it. Remember, you can't combine like terms here, so I'll write this as negative 2x plus y equals negative 9. My ax plus by equals c in standard form. After that overload of information, it's time for you to try. Go ahead and find x and y intercepts, convert to slope-intercept form, and sketch your graph. Pause the video here and come back when you're finished. I went ahead and found my x and y intercepts first. As you can see, my x-intercept is 1/4 comma 0, and my y-intercept is 0, 1. I also converted this to slope-intercept form by subtracting 4x from both sides and getting y equals negative 4x plus 1. After finding my intercepts, I can go ahead and plot this on a graph using the slope and the y-intercept. My slope is negative 4 over 1, which means I can move down and to the right. I'm going to start at my y-intercept, which is 0, 1, and plot a point. And then I'll count 4 down, 1, 2, 3, 4, to the right 1. I want to see some more points above that. So if I can move down right, I can move the exact opposite, which is up left. This will still give me a negative slope. So I start again at that y-intercept and I move the opposite direction, up 4, left 1. Notice how it's still on the same line and we still have a negative slope. Notice how we're also able to see our x-intercept 1/4 0 here. You'll also see some equations that are either missing an x or a y. When you're looking at vertical lines, this is where you have x equals some number and your slope is undefined. These are not functions. When you're looking at horizontal lines, you'll have y equals some number and your slope is 0. This is a function because it'll pass the vertical line test. Let's take a look at the example x equals negative 4. I'm going to find the x value at negative 4. Every x value will have to be equal to negative 4 here. So notice how as I plot points, it creates a vertical line. All of those x's are at negative 4. It doesn't matter how many values we move up or down. What matters is for a vertical line, we'll never move to the right or to the left. So this bottom number, or the run, will always be 0. Any number over 0 is undefined. So to look at another example, like x equals 2, I'll start at x equals 2 and I'll move up and down however many points I want, but I'll never move to the right or to the left. That's what makes this a vertical line or a line with an undefined slope. Let's go ahead and take a look at y equals 2. If I plot a point at y equals 2, no matter what x value I choose here, that y value will still be at y equals 2. That's what creates this horizontal line. which is a function. It passes the vertical line test. We'll go ahead and take a look at a different example, like y equals -3. Notice how for a horizontal line, I move to the left and to the right as many times as I want, but I move up and down 0, which is why my slope here is 0. The last thing we'll look at today is parallel versus perpendicular lines. Parallel lines have the exact same slope, so notice how both of these slopes are 2. Perpendicular lines have opposite reciprocal slopes. So notice how the first slope is -2 and the opposite reciprocal of -2 is +1/2. Go ahead and pause the video here. Graph the parallel lines on their own coordinate plane and the perpendicular lines on their own coordinate plane. Notice how these lines are parallel, which means they will never intersect. It's a sketch of a graph, so obviously these lines aren't completely perfect, but you can see that they look similar to the lines on our paper, to these blue lines on our paper. They're going in the exact same direction. They're parallel. They have the same slope. They will never intersect. When we take a look at these two lines, we call them perpendicular because they have opposite reciprocal slopes and they're going to intersect perpendicularly. That means that they make a 90-degree angle at their intersection point. Thanks for stopping by to learn about graphing lines. We'll see you next time.